The next section we're going to talk about is called factoring. So I have some notes here that I would like you to write down either in your notebook or on a sheet of paper because we're going to do a few examples together. So let me scroll this down. Factoring, I like to think of it as the opposite of distributing. So a way to check if I factored correctly is to do the opposite, which is the distributive property. So take a look at this expression, 12x plus 3. Can I combine them? No, they're not like terms. Okay, but I can factor this expression. So in order to factor, you have to think of a common factor. And actually, we're going to look for the greatest common factor. Remember GCF? We're going to use it in this section. So we're going to think of each term separately. So here is the first term, 12x, and the second term is 3. What is the greatest common factor between 12x and 3? Well, they both don't have an x, so that's something they don't have in common. So really, we're going to be focused on the 12 and the 3. So let's move this down. Okay, and if I think of 12 and 3, what is the greatest common factor? Well, it has to be 3 because the only factors of 3 are 1 and 3, and we're not going to use 1. So my GCF is 3. So in order to factor this, you take the GCF out of each term. And what I mean by that is you're going to divide both 12x by 3 and 3 by 3. So you're going to divide both terms by the GCF. Okay, so here I've pulled out my GCF, which I'm going to write outside the parentheses. And then inside the parentheses is everything that's left over after I divide. So let me change the color here. If I have 12x and I'm dividing it by my GCF of 3, what's 12x divided by 3? 4x. Plus, now divide the last term. What is 3 divided by 3? 1. This is the factored form of this expression. They are equivalent. Okay, and we love to check our work. So let me erase this real quick now that I made a mess. So we love to check our work. So how can I check that I factored correctly? Well, all you do is the opposite and distribute. What's 3 times 4x? Boom, 12x. And what's 3 times positive 1? Boom, 3, I'm sorry. So therefore, we have factored correctly because we get the same answer once we distribute. Okay? So let's take a look. Before we do some examples, let's review greatest common factor because some of you still might be scratching your head. Remember, factors are numbers that are divisible by that number. So when I'm talking about factors of 12, right, we tend to confuse factors with multiples. Multiples of 12 are 12, 24, 36, 48, and they go on and on and on and never end. However, 12 only has a few factors. It has 1 and 12, right? That will get me 12. It has 2 and 6, and it has 3 and 4. So these are my factors of 12. Let me move this down. Now, what are the factors of 20? Well, I could do 1 times 20, 2 times 10, and 4 times 5, right? 3 doesn't work, 6, 7, 8, 9, nope. So looking at the factors of 12 and 20, what is the greatest factor that they have in common? And it would be lucky number 4. What about if I asked you for the GCF of 5 and 15? Well, let's list out the factors of 5. 5 has 1 and 5. That's it. 15 has 1, 3, 5, and 15. So the GCF here would be lucky number 5. So let's take a look at some examples. So what I want you to do right now is pause the video, copy down all of the examples in your notes or your notebook, okay? And I would like you to try them before I do them for you. So let's just do 11 and 12 together, then pause the video and try to figure out the rest, okay? Then play back the video to see if you did it correct. So the first example, number 11, is 3x plus 3. I'm going to factor them, so I need to think, what's the GCF between 3x and 3? Well, that's an easy one. The GCF would just be 3, and then I set up my parentheses. Now I'm going to divide both these terms by 3, and whatever I get goes inside here. So 3x divided by 3, this is a 3, is just 1x plus, I really apologize for my pen. It would be a little bit easier if I had an iPad. And then do the last term. 3 divided by 3 is 1. And again, who doesn't love to check their work and make sure they did it correctly? If you were to distribute this, you get this same expression, so you did it correctly. This is the factored form of this expression. Number 12, let's do together. 4x plus 6. What is the greatest common factor between 4x and 6? Well, not the x, because they both don't have that in common. So I'm looking at 4 and 6. Factors of 4, 1, 2, 4. Factors of 6, 1, 2, 3, 6. So there you have it. It is 2. If I divide both terms here by 2, what do I get? Well, 4x divided by 2 is 2x plus, what is 6 divided by 2? 3. These two expressions are equivalent, right? Let's put a little equal sign there to remember that they're equivalent. And the way to double check is to distribute. 2 times 2x is 4x, and 2 times 3 is 6. Ding, 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 we did it right. So now pause the video, do 13 to 26, and then play back the video when you're done to check your solutions. Okay, hit pause. So if I'm going to erase this and I'm going to type the answers just so it's a little bit neater. So I have 3 times 1x plus 1 goes here. Okay, so what'd you get for number 13? You should have 2 times the quantity of, remember parentheses we say times the quantity of, 4 plus 3y. Double check it by distributing, you got it correct. Number 14, 5y minus 10. The GCF is 5, so you're left with 1y, or let's just put y, minus 2. Okay, double check by distributing. Number 15, GCF between 4 and 10z is 2. What's left? 4 divided by 2 is 2 minus 5z. These two expressions are equivalent. Number 16, the GCF between 12 and 8 would be 4. 12 divided by 4 is 3 minus 2x. Number 17, 8f plus 6. My GCF is 2. And then I divide both by 2 and I get 4f plus 3. Number 18, 12t minus 8. What's the GCF here? It would be 4, right? Again, the 12 and the 8. And then I would have a 3t minus 2. Number 19, what's the GCF between 15 and 5? Well, we just did that one on the last slide. It would be 5. 15 divided by 5 is 3 plus 1q. Or you could just write q. And number 20, 32m minus 8. What's the GCF between 32? Oh, I said 8. What's the GCF between 32m minus 40? That's 8. So if I divide 8 by both of these, you're left with 4m minus 5. Again, just double check by distributing it. The last 6, you had to state whether the expressions are equivalent. So you're going to want to multiply all of these using the distributive property. So here, if I were to multiply this little expression out, I would get 8x plus 6. Are they equivalent? Yes, they are. Number 22, if I multiply this out, you get 3y plus 18. Are those equivalent? Well, order doesn't matter in addition, so yes, this is equivalent. Number 23, if I multiply this with the distributive property, I get 5x minus 25. Are these equivalent? No, it is not equivalent to 5x minus 10. Number 24, if I distribute this 4 to the y minus 4, I get 4y minus 16. Ooh, whoa, too small, too small. Is that equivalent to this? These are actually not equivalent because if you look at the signs, this 4y is negative and this one is positive. This 16 has a minus in front of it and this one doesn't, so this is not equivalent. We also said this one, right? So let's give it an X. Not equivalent. Number 25, I have 3x plus 15. This is indeed equivalent. Order doesn't matter in addition. And number 26, if I multiply this with the distributive property, I get 8y minus 12. And let's check these two. This one is also not equivalent because this has a minus 8y, and here mine's positive. Same goes for the 12. This 12 is a positive, but this one is negative. So this is not equivalent. And that is how you factor.